Aldehydes and ketones react via a nucleophilic addition mechanism, whereby a nucleophile, that's a negatively charged ion or a neutral molecule that can donate a pair of electrons to form a covalent bond, attacks the delta positive carbon atom of the carbonyl group. In this video, I'm going to show you the mechanism, and the nucleophile will be a cyanide ion. The cyanide ion is generated in situ when sodium cyanide is acidified with sulfuric acid. The lone pair of electrons on the ion attacks the delta positive carbon, and electrons from the pi part of the double bond move on to the oxygen atom. In the intermediate, we can see the new bond formed between the nucleophile and the carbon of the carbonyl group, and the oxygen carries a negative charge. The oxygen is able to get rid of its negative charge by abstracting a hydrogen ion from another hydrogen cyanide molecule, and the electrons from that bond move on to the cyanide to form a cyanide ion. The resulting product has both the cyanide ion bonded to the carbon, and the oxygen has become an alcohol group. It's worth noting that both the steps in this mechanism are reversible. The position of equilibrium actually lies to the left for ketones, especially those with bulky R groups. The reason for this? Well, bulky alkyl groups bonded to the delta positive carbon put a steric strain on the central carbon atom during the reaction. In fact, in general, ketones react more slowly than aldehydes because these alkyl groups literally physically get in the way of nucleophiles attacking the delta positive carbon. And it's also worth noting that alkyl groups are electron donating. They push electron density towards the delta positive carbon to help stabilize the charge, and hence that carbon is now less attractive to nucleophiles. The addition of a cyanide ion to an aldehyde or ketone to form a hydroxynitrile, also known as a cyanohydrin molecule, is an important reaction for synthesis purposes because we're forming a new carbon-carbon bond. We've added another carbon to the chain. The nitrile group can be easily hydrolyzed by heating with aqueous acid. In the first step, water is added and we form an amide group, and the amide group itself is easily hydrolyzed to form a carboxylic acid. If this has been helpful, then please like, share, subscribe. It makes a huge difference to a small channel like us. Crunch Chemistry, everything you need to know for A-level.